Americans can't believe what China built now, and honestly, you won't either. Right now, one of the most watched broadcasts on the planet just featured humanoid robots performing synchronized dances on live television in front of 800 million viewers. You heard that right, 800 million. That's 2.5 times the entire US population watching simultaneously. This wasn't just entertainment, it was a declaration. These robots aren't prototypes, they're real. They're here, and they're preparing to do the jobs your neighbors will do tomorrow. But the real story isn't about dancing machines. It's about survival, strategy, and who controls the future. Now, let's start with the moment that changed everything. The jaw-dropping moment. Picture this. It's February, and across China, families are gathered around their televisions for the CCTV Spring Festival Gala, the Chinese New Year broadcast that has no equal anywhere on Earth. This isn't just a show. This is a cultural institution. For decades, hundreds of millions of Chinese families have made this broadcast a tradition, a moment where the entire nation tunes in together. The viewership numbers are staggering. We're talking about more than 800 million people watching simultaneously. You heard that right, 800 million. That's nearly 2.5 times the entire population of the United States, all watching the same broadcast at the same time. And then something happened that nobody expected. On that stage, among the traditional dancers and performers, something moved that looked almost human. But it wasn't human, it was metal. It was precision engineering. It was a humanoid robot, and it was dancing. But this wasn't just one robot awkwardly shuffling across the stage. This was a choreographed performance. Multiple robots, moving in perfect synchronization, executing moves that required balance, timing, and coordination that roboticists in the West are still years away from achieving. The robots weren't jerky or mechanical in that obvious way you'd expect from machines. They were fluid. They were graceful. They were, for lack of a better word, mesmerizing. And the moment they appeared on screen, the entire context of what China was doing became suddenly, shockingly clear. This wasn't a technology demonstration hidden away in a laboratory for engineers to marvel at. This was a statement. This was China telling the world, and more importantly, telling its own people that the future had already arrived. And it was made in China. The robots glided across the stage with an elegance that defied what you thought was possible from machines. Their movements were synchronized perfectly with the music, their arms moving in unison, their steps timed to the beat. For the first time, the line between human performance and machine capability blurred right before 800 million eyes. But what you saw that night was just the surface. Beneath the spectacle, beneath the choreography, and the perfectly timed movements, something far more significant was happening. These weren't just entertainment robots. They were proof of concept. They were a preview of what's about to transform the entire global economy. And the companies building them? They're about to become the most powerful robotics manufacturers the world has ever seen. Meet the giants. You need to understand something crucial. The robots you saw dancing on that stage didn't appear out of nowhere. They were built by companies that most Americans have never heard of. But that's about to change. These aren't garage startups or academic experiments. These are serious manufacturing operations backed by serious money, serious talent, and serious ambition. And they're moving at a speed that should make Silicon Valley nervous. Let's start with Unitree Robotics. If you haven't heard of them, you're about to. Unitree has become one of the most aggressive innovators in bipedal robotics. That's robots that walk on two legs like humans do. Their humanoid robots can walk at speeds that rival human walking. They can climb stairs, they can navigate complex terrain, and they can do it all while maintaining perfect balance. What makes Unitree terrifying to Western competitors is their speed of iteration. They're not spending years perfecting one prototype. They're releasing new models, testing them in the real world, gathering data, and improving them at a pace that would make traditional robotics companies look like they're moving in slow motion. They've already demonstrated robots that can walk backward, sideways, and perform movements that require real-time adjustment and balance correction. Then there's UBTECH Robotics. UBTECH has taken a different approach. While they've built impressive bipedal robots, they've also focused heavily on making robotics accessible and scalable. UBTECH understands that the real money isn't in building one perfect robot. It's in building systems that can be mass-produced, deployed across industries, and upgraded continuously. They've positioned themselves as the company that will put robots into factories, warehouses, and service industries across China and beyond. Their robots aren't just technically impressive, they're designed to be practical, maintainable, and profitable. But here's where it gets really interesting. Fourier Intelligence has taken yet another path. Fourier is obsessed with dexterity, the ability for robots to manipulate objects with precision and finesse. They understand that a robot that can walk is impressive, but a robot that can walk, pick up an object, and perform delicate tasks, that's a robot that can actually do real work. Fourier's robots have demonstrated the ability to perform complex hand movements, to grasp objects with varying levels of pressure, and to execute tasks that require real problem-solving capability. What's shocking is that these three companies aren't competing in isolation. They're part of an entire ecosystem of robotics companies, suppliers, and innovators all working in China right now. Unitree, UBTECH, Fourier, they're just the most visible names. But behind them are dozens of other companies, all pushing boundaries, all innovating rapidly, all racing to dominate different segments of the robotics market. The real tension here is this: while Western robotics companies are still debating timelines and feasibility, these Chinese companies are already shipping products. They're already deploying robots in real-world scenarios, and they're already learning from those deployments, iterating, improving, and getting better every single day. But what these companies are building isn't just impressive engineering. It's the foundation for something much larger, a complete reimagining of what's possible when you combine advanced robotics with manufacturing at massive scale. From walking to dancing. You might think that humanoid robots are still years away from being truly useful. You might imagine them as clumsy, falling over, unable to do anything without human supervision. Think again. What's happening right now in Chinese robotics labs is so far beyond what you probably imagine that it's almost difficult to articulate without sounding like science fiction. But it's not science fiction. It's happening today, right now, in factories and laboratories across China. Let's talk about what these robots can actually do, because this is where the jaw-dropping part really begins. The humanoid robots you see coming out of these Chinese companies aren't just walking forward in a straight line. They're doing things that required years of research and development to achieve. They're walking on uneven terrain. They're climbing stairs, not carefully, not slowly, but naturally, the way a human would climb stairs. They're maintaining balance on slippery surfaces. They're adjusting their posture in real time as they encounter obstacles. This is happening through advanced sensor systems, artificial intelligence processing, visual data, and algorithms that can make split-second decisions about weight distribution and movement. But walking is just the foundation. The real revolution is what comes next. These robots are dancing. And when I say dancing, I don't mean simple repetitive movements. I mean coordinated, rhythmic, graceful movements that require understanding music, timing, and spatial awareness. To dance, a robot has to process audio in real time, predict the next beat, coordinate multiple joints simultaneously, and maintain perfect balance while executing movements that, frankly, would be impossible for a machine even 5 years ago. Then there's manipulation, the ability to pick things up and move them. You might think, well, robots have been picking things up for decades. True, but industrial robots are bolted to the floor, they work in controlled environments, and they perform the same task thousands of times. The humanoid robots we're talking about can pick up objects of different shapes and sizes, adjust their grip based on the weight and fragility of the object, carry items while walking, and place them down precisely. Some of these robots can now carry loads of 50 to 100 pounds while maintaining balance and navigating obstacles. But here's what really separates what's happening now from what was possible just a few years ago: dexterity. These robots are developing the ability to use their hands in sophisticated ways. We're talking about robots that can pick up a pen and write, robots that can manipulate small objects with precision, robots that can perform tasks that require fine motor control. Fourier Intelligence has demonstrated robots performing surgical precision tasks. UBTECH robots can execute assembly line work that previously required human hands. And this is just the beginning. These capabilities are expanding every single month. New demonstrations show robots learning from human movements, robots adapting to new tasks, robots improving their performance through trial and error. The speed of improvement is accelerating, and each breakthrough opens up new possibilities for what these machines can do. But here's the tension that nobody's talking about. While Western companies are still trying to build the first generation of practical humanoid robots, China is already moving into the second and third generations. They're not asking, can we build a robot that walks? They're asking, what industrial jobs can we have robots do by next year? And that's a fundamentally different question, one that suggests a fundamentally different future. China's dominance. You probably didn't know this, but China isn't just competing in robotics, it's already winning by a landslide. And the numbers are so staggering that they should completely reshape how you think about the global economy and where innovation is actually happening right now. Here's the reality. China is the world's largest market for industrial robots. Not by a little bit, by a massive margin. We're talking about more than 500,000 industrial robots deployed in Chinese factories and manufacturing facilities. To put that in perspective, that's more robots than exist in Europe and North America combined. You heard that right, more robots than exist in Europe and North America combined. And that number isn't staying still. It's growing every single year at double-digit rates. But it gets worse or better, depending on your perspective. China doesn't just buy the most robots. China is now the world's leading manufacturer of robots. Chinese companies are shipping more robots globally than any other nation. The export numbers are stunning. Chinese robotics companies are selling to factories in Europe, in Southeast Asia, in Latin America, and everywhere else that needs manufacturing automation. While Western robotics companies were still perfecting their pitch decks, Chinese companies were already scaling production, lowering costs, and dominating market share. This is the part that should make you pause and really think about what's happening. The United States, which invented so much of the foundational robotics technology, is now a secondary player in the global robotics market. Japan, which dominated industrial robotics for decades, is watching its market share erode as Chinese companies undercut them on price while matching them on quality. Europe is struggling to keep up. And all of this happened in the span of just a few years. The numbers tell the story. In 2023 alone, China shipped more than 450,000 industrial robots. That's not a typo. 450,000 units in a single year. The global total? Around 630,000 robots shipped worldwide. Which means China is responsible for roughly 70% of all robot shipments globally. Let that sink in. 7 out of every 10 robots being deployed anywhere on Earth right now are Chinese-made. But here's what makes this even more significant. The profit margins on these robots are getting thinner as Chinese companies compete on price, but the volume is making up for it. And volume creates something far more valuable than short-term profit. Volume creates data. Volume creates learning. Volume creates the ability to iterate and improve faster than competitors who are selling smaller numbers at higher price points. And it's not just the robots themselves. China is building an entire ecosystem around robotics. They're developing the software, the AI systems, the supply chains, and the manufacturing expertise that makes the whole system work. When a Western company wants to compete, they have to build all of that from scratch. When a Chinese company wants to expand, they just tap into infrastructure that already exists. But the most terrifying part? This dominance in industrial robots is just the warm-up act. The real game is humanoid robots machines that can do almost any job a human can do. And China is about to launch that revolution at a scale that will make their current dominance in industrial robotics look quaint. The supply chain advantage. You might wonder how Chinese robotics companies are able to move so fast, innovate so rapidly, and bring new products to market in months instead of years. The answer isn't magic, it's infrastructure. And it's something that took decades to build, but now gives China an almost insurmountable advantage in the robotics race. Imagine you're a robotics engineer in Silicon Valley. You have a brilliant idea for a new robot. You sketch out the design. You need components, servo motors, actuators, sensors, processors, structural materials, circuit boards, wiring, connectors, everything. Where do you go? You spend weeks sourcing components from different suppliers, many of whom are on the other side of the world. You wait for shipments. You deal with supply chain delays. You pay premium prices because you're ordering in small quantities. You build a prototype. It doesn't work perfectly. You identify what needs to change. You wait for new components to arrive. The cycle is slow. The process is expensive. The timeline stretches out. Now imagine you're a robotics engineer in Shenzhen, China. You have the same brilliant idea. You walk down the street. Within a few blocks, you can find suppliers for almost every component you need. Want servo motors? There's a factory that makes them. Need custom circuit boards? There's a manufacturer around the corner. Want to outsource assembly? There are dozens of companies that specialize in exactly what you need. You can order components in the morning, have them by afternoon, build a prototype by evening, test it, identify improvements, and have new components ordered before you go to bed. The iteration cycle is measured in days, not months. This isn't exaggeration. This is the reality of operating in a manufacturing ecosystem that's been optimized over decades. China has the densest concentration of robotics component manufacturers, electronic suppliers, and precision manufacturing facilities anywhere on Earth. It's not just one advantage, it's dozens of advantages, all stacking on top of each other. But there's more. Cost. Because of competition, because of scale, because of efficiency, components cost less in China. A servo motor that costs $100 in the United States might cost $30 in Shenzhen. That's not because of lower quality, it's because of volume and competition. When you're building hundreds of thousands of robots, that cost difference becomes transformative. It means you can afford to build more prototypes. It means you can afford to fail and try again. It means you can price your final product aggressively and still make profit. Then there's the workforce. In Silicon Valley, you're competing for talent with every other tech company on the planet. Salaries are astronomical. The common issue: salaries? In China, especially outside the major coastal cities, you can hire talented engineers and manufacturers for a fraction of what you'd pay in the West. That doesn't mean the talent is lower quality. It means the cost structure is fundamentally different. And here's the kicker. Chinese companies have government support that helps subsidize research and development, that helps fund factories, that helps keep costs down through various incentive programs. Western competitors don't have that same level of support. They're operating in a pure market environment, trying to compete against companies that have explicit government backing. The result? Chinese robotics companies can develop new robots faster, test them more thoroughly, iterate more rapidly, and bring them to market cheaper than competitors anywhere else. By the time a Western company brings a robot to market, a Chinese company has already sold 10,000 units, learned from the data, built a second generation, and is working on a third. This supply chain advantage isn't temporary, it's structural. It's not going away. In fact, it's only getting stronger as more companies enter the market and the ecosystem becomes even more optimized and specialized. Government support and strategic planning. You need to understand something fundamental about how China approaches technology development, and it's radically different from how the West thinks about innovation. In America, we assume that technology advances through competition and market forces. Companies compete, the best products win, and innovation happens as a byproduct. In China, the government has decided that robotics is a strategic national priority, and they're willing to deploy massive resources to ensure that China dominates this space globally. This isn't conspiracy theory. This is explicit policy. The Chinese government has identified robotics, and specifically humanoid robots, as critical to China's future economic competitiveness. They've made this a priority in their 5-year plans. They've allocated billions in research funding. They've created tax incentives for robotics companies. They've funded robotics research centers and innovation hubs. They've essentially said to Chinese companies, "We're betting on you. We're backing you. Now go win." The specifics matter here. The government provides direct subsidies to robotics companies for research and development. Companies that demonstrate progress in humanoid robotics get funding boosts. Universities receive grants to train roboticists and engineers. Manufacturing facilities get tax breaks if they meet robotics production targets. It's not subtle. It's a coordinated top-down strategy to create a robotics superpower. And it's working. Companies like Unitree, UBTECH, and Fourier Intelligence didn't become world leaders by accident. They became world leaders because they had government support, government funding, and government backing that allowed them to take risks that private companies in the West simply cannot afford to take. But here's where it gets really interesting. The government isn't just throwing money at companies and hoping something sticks. They have a clear vision for what they want to achieve. They want China to develop humanoid robots that can be deployed at industrial scale. They want to create an ecosystem where humanoid robots become as common in manufacturing and service industries as traditional industrial robots are today. They want to solve China's labor shortage problem with machines instead of workers. This is a multi-decade strategy. The government isn't expecting results next year or the year after. They're thinking 10, 20, 30 years out. They're willing to invest massive resources now to ensure that China dominates this technology for decades to come. And they're not waiting for perfect proof of concept. They're funding deployment, real-world testing, and industrial applications right now. The tension here is stark. Western companies are trying to develop robots that are profitable in the short term. Chinese companies are being funded to develop robots that will dominate the market long term, even if it means accepting lower profit margins and operating at a loss for years. When you're backed by a government with effectively unlimited resources, you can make decisions that private companies simply cannot make. And this strategic planning, this long-term vision, this willingness to invest massive resources, it's accelerating the robotics revolution in ways that Western observers are only beginning to understand. The aging population crisis. You've probably heard that China has an aging population problem, but you might not understand just how existential this crisis really is. China's workforce is shrinking fast. By 2050, China will have fewer working-age people than retirees. Think about what that means economically. Fewer people paying taxes, fewer people producing goods, fewer people driving economic growth. It's a demographic catastrophe that threatens to collapse China's entire economic engine. But instead of panicking, instead of hoping the problem solves itself, China made a bold bet. They decided to replace human workers with machines. Humanoid robots aren't just cool technology to them. They're a survival strategy. They're the answer to a question that keeps Chinese policymakers up at night. How do we maintain economic growth when we don't have enough people to work? That's why the government is pouring billions into robotics. That's why companies are racing to develop humanoid robots that can do real industrial work. That's why every breakthrough in robotics capability is celebrated as a national achievement. These machines aren't luxury items. They're essential infrastructure for China's economic future. And they're coming faster than anyone expected.